Hello students, how are you? Today I'm going to talk about chirality without chiral center. Okay, chirality without chiral center. It means that there is something is present for happening of optical activity, which is in the today case this is chiral axis. So first of all, I'm going to talk about types of double bond. Okay, so without wasting any time, let's get started. Double bond. There is a three type of double bond. Sorry. There is three types of double bond. First one is cumulated. There is one M, I think so, but little bit doubt with the spelling. So adjust. What's about okay? Another one is conjugated. You are very well familiar with this. What about isolated? As the name is indicating, isolated system. So these are three types of double bonds. So double bond, C, H and H. Okay, H and H. Okay, this is cumulated double bond. What's the hybridization of middle one carbon? It is sp. What's about this? sp2. What's about this? sp2. In the conjugated, as you know, there is double bond C, single bond C, double bond C, CH2, CH2. So CH and there is H also at here. This is sp2. This one also sp2. This one also sp2. This is also sp2. Okay. Okay. What's about isolated double bond? So double bond C single, C single, and C double bond CH2. There is a H and this completing the valency of it. H, H, H and H. This is sp2. This is S also sp2. This is sp3. This is sp2 and this is sp2. So here there is a three types of double bonds. We needed this type of double bonds for showing chirality without chiral center. So I just show you the types of double bonds. Okay, we needed this one. So let's start. The answer is hidden in the types of bond which one is forming sigma and pi bond. So just take internuclear axis. I am just taking X, this is Y and this is Z. Okay, this is very important because this will tell you how it's become chiral. And I am going to draw center. This is sigma bond which is along Z x-axis. This is along x-axis. So P bond or pi bond I needed because, as you know, central carbon atom is forming two pi bonds and the side one is forming only one. So I need to show two p orbitals on the center and one on the both side one. Okay. Now as you can see, if this one is py, this one is py of central atom and this one is pz, this one is pz. Okay, if this py orbital is forming bond with this terminal carbon atom, pi bond with this terminal carbon atom, then the py orbital of central atom will not be available for forming pi bond for the corner one. That's why I have to take another p orbital of the central atom for forming pi bond from the another terminal carbon atom, which one in this structure is present on the right hand side. So I am just forming pi bond at here. As you know, all p orbitals are perpendicular to each other, as you can see at here. It means that these are perpendicular to each other. It means that the group which are coming at here, let's hope this is X, A, this is B, and this is, just use another marker, H, and this is H. As you can see, this one is just perpendicular to each other. It means that the A, not H, A and B in this case is coming towards, A is coming towards viewer and just B is going away from the viewer. What's about this? A and B, it's in the plane. So these are perpendicular. What's about A? If A is equal to B, it means that if I'm going to take all of these as H, if I'm going to replace A and B from H, so I'm replacing it here because I want to show you how it's become optically inactive. If you want to take a plane from at here, it will cut this H, but this H will be not gonna to cut by the plane which I am using, and that plane is plane which I am using at here, XY plane. Then mirror image of this H will form on this H. It means that it become optically inactive due to existence of planar symmetry. What's about at here? If I'm going to use a plane at here of like this, it means that the plane which I'm going to use from this side, that one is XY plane. That one XY plane. It means that if I'm using that one XY plane, it will cut this hydrogen and this hydrogen sphere into two halves. But what about this hydrogen? The image of this hydrogen will form on this hydrogen. It means that it's become optically inactive due to existence of planar symmetry. What's about planar symmetry exists? So planar symmetry exists, then it's become achiral. What's about if I'm going to take, if A does not equal to B, so plane will be same. Just writing again. If A does not equal to B, let's assume if A is equal to H and B is equal to deuterium. As you know, if isotopes comes in the purity rule, then we give priority to that isotope which have more atomic weight. Okay, it means that deuterium has more priority than hydrogen. So I am going to replace A and B from this. There was A, so I am going to replace A from H and B from D. A was here, so I am going to replace H and D. If I am going to use plane format here, which is XY plane, if I want to cut like this, then it will be cut into half. A sphere of hydrogen at here also cuts into half. But what's about at here? The image of H forms on D, or D image forms of H. It is not same. It means that there is no central symmetry, or sorry, in this case there is no POS exists if A and B is not same. If A and B are not same, there is no planar symmetry will exist at here. It means that it become chiral. It's become chiral. Why is happening? Because there is no POS of S is existing now in this compound. From here you can take the another plane, XY plane. If you are going to take, then it will cut this sphere into half. But what about here? Mirror image of D forms on H and H's mirror image of form on D. This is not same atom. It means that this compound become chiral due to chiral axis, not due to chiral center. Now, so how you calculate RS configuration in this type of compound? So now I'm going to take an example. I have to remove it first, but I'm not going to remove that one because I can do it here. Okay, so you have to just look from both sides. First of all, the bond which one is coming towards you, first of all you have to just give the numbering to that bonds. As I am standing at here, I can see these bonds are coming towards me, and properly I can see right hand side is H, my on my left hand side is H, on my left hand side is D. So as you know, I taught you earlier, if there is isotope is present, the priority goes to higher atomic weight. So 1 and 2. Okay, this is right hand side, this is left hand side. D is coming left hand side because these two bonds are coming towards me where I am standing at this time. I am seeing from here. And what's about that one? So there is 3 would be here because between these two purity goes to D, then H. What's about 4? So 1, 2, 3. There is a S configuration will come from this side. If you are not wrong, then the if you want to check if you are not wrong, then if you see from it here, the absolute configuration will be same. So I am going to check from this side also. As I can see, these bonds are going away from me and these bonds are coming towards me, and D is coming at here and H is coming at here. It means that in this case I have to draw first vertical line. D is upside, it means that 1 and 2. What's about this? Now D is on my right hand side, D is on my right hand side, and H on my left hand side. This is 4. What's about this? 3, and this is 1, 2, 3, 1, 2, 3, 4. It means this is S. In this case, there is a if lowest priority group is if it is coming in the horizontal plane, there is no need to change or reverse the configuration. In this case, lowest priority group, there is no rule of lowest priority group. So if it is coming, let it be 1, 2, 3. This is S. It means that the configuration S is right of this compound. So going to take another one to solve it. Lots of question depends on it. If you deal with it allenes compound, then you can solve number of question which is just directly depend upon it. So basically where we were, so I am going to take double bond this. Remember, this is communicated double bond is 2, only 2, not 3. Be careful with it. Okay, if a completely double bond becomes 3, the compound become chiral. Whether you use A is equal to B, whether you use or you use A does not equal to B, it's become chiral because there is a plane of symmetry will exist in that one. Okay, I am going to take CS3 and Cl at here. Cl and CS3. In the question, for making you confused, this will not return. This will be not written like this. This will be written like this. You have to know that these all compound, these all molecules coming in the same plane or not. Okay. For showing that these all molecules are not coming in the same plane, that's why I just show you the bonding and overlapping between p orbitals. Okay. So the real structure is this one, but question may be asked like this. So from here, as you can see, these two bonds are coming towards me. So from here, as I can see, Cl is coming right hand side and CS3 is coming on left hand side. So you know very well about it. Atomic number of Cl is greater than C, then 1, 2, up and down, 3 and 4. This is S. So it is right or wrong. Check from this side also. Vertical, because these two bonds are coming towards me from this side. So 1, 2, and CS3 will be right hand side and this is left hand side. Cl at here, it means 3 and 4. As you can see, there is a 1, 2, 3 is coming. It means that this is S. There is no rule of lowest priority group which come in the horizontal plane. No need to change or reverse the absolute configuration. Okay. So S you can see, but number of double bond, completed double bond must be 2 or even, not odd. Okay, this is even for making this compound chiral if A does not equal to B. in the case of A equal to B becomes a chiral whether communicated double bond is present in even number or odd number. Nothing is going to be changed. So I am going to talk about if there is a double bond in odd number. So if this is PY, I am going to use 2 1, this one, because there is a 2 double bonds formed, so I am going to use this one also. Okay, as you can see, I am going to form this by this p orbital form pi bond by this. As you can see, this p orbital is not available for binding with this one, so there is a perpendicular between, you can say that pz orbital, this is py orbital, so this form pi bond at here, so this is available for the terminal one. Now you can see, hold on for a second, I am going to use another marker for making it clear. Now, okay. Now as you can see, terminal P, this is terminal py orbital, and this is also py orbital. This means that, as you can see, the pi orbital which is forming by terminal carbon are same. It means that the sigma bond of both terminal carbons will come in the same plane. It means that whether it's same or not, there is a plane of symmetry will exist if number of communicated double bond is in an odd number. Whether it's 3, whether it's 5, it doesn't matter. It will become same because there is a plane of symmetry will exist. How it will exist? Z, X, Y. If you want to use, just use XZ plane. It will bisect this molecule. Okay. Whether it is A equal to B, A equal to B, in both case POS will exist and compound become a chiral. Okay. So I given you lots of information about chirality without chiral center. So I think this is going to be big. So I am just stopping at here, and in the next video there's a lots of questions based on this type of basic alkenes molecule. So I'll talk, or we will discuss in the next video. Okay, till then stay tuned.